An archer shoots an arrow in a field. Suppose the equation y equals negative 0.02x squared plus 1.3x plus 8 models the trajectory of the arrow. Assume that x and y represent distances in meters and that x and y are both greater than or equal to 0. A. What is the maximum height the arrow reaches? B. How far does the arrow travel horizontally? And C. Graph the trajectory of the arrow. A. Let's find the maximum height the arrow reaches, and this will happen at the vertex of this parabolic path, the vertex of this parabola. So we know to find the x-coordinate of the vertex. The x-coordinate of the vertex is found by using negative b over 2a. So we'll have negative b. B is 1.3 over 2 times a. A is negative 0.02. Negative 0.02. And when we take negative 1.3, divide that by 2 times negative 0.02, we get 32.5, 32.5. So again, this is the x-coordinate of the vertex. We will now substitute this value back into the equation to get the corresponding y-coordinate of the vertex. So substituting 32.5 into x into our equation, we get y equals negative 0.02 times x, 32.5, squared, plus 1.3 times x, which is 32.5, and then we'll add 8, and when you do the arithmetic, we get 29.125. 29.125. So again, this is the x-coordinate of the vertex, 32.5, comma, y-coordinate of the vertex, 29.125. So I'm going to write that as a ordered pair. The maximum height would be the y-coordinate of the vertex. So the maximum height reached is 29.125 meters. B. How far does the arrow travel horizontally? And to answer this, we want to know, when does the arrow actually, hit the ground again? And that's going to happen when we let the function equal 0. So we're going to set the function or the equation equal to 0. So we'll have negative 0.02x squared plus 1.3x plus 8, and we'll set it to equal to 0, and we'll find out how far horizontally must the arrow travel in order for the vertical distance to equal 0, meaning it's hit the ground. So we're going to go ahead and use the quadratic formula. We have x equals negative b, negative 1.3, plus or minus the square root of b squared, 1.3 squared, minus 4 times a. A is negative 0.02 times c, which is 8. All of that over 2 times a, or 2 times negative 0.02. Simplifying further, we have negative 1.3 plus or minus the square root of doing the arithmetic, 1.3 squared minus 4 times the value negative 0.02 times 8 gives us the square root of positive 2.33, all of that over negative 0.04. And again, we're going to crank out two x values. This would imply that x would equal negative 1.3 minus the square root of 2.33 over negative 0.04 gives us negative 5.66, and the other x value that we get, negative 1.3 plus the square root of 2.33 divided by negative 0.04, gives us 70.66. And recall, x is how far the arrow travels horizontally, therefore we must throw out the negative value. It's an extraneous value. So the x coordinate, the x value of where y equals 0, 70.66, so the arrow travels 70.66 meters horizontally. So answer to part B is 70.66. C, graph the trajectory of the arrow. We're going to plot a couple points that we know that that fall on the trajectory, and we'll try to connect those with a parabolic curve. We know at the very beginning, if I let x be 0, meaning the arrow did not travel any distance horizontally, y is at positive 8. So the y-intercept is at 0, positive 8. So we'll just go up a little bit. And then as we travel horizontally, we know that the vertex occurs at 32.5, 29.125. So a little over 30 on the x-axis, not quite 30 on the y. 30, 30. So a little over 30, not quite 30. So right about here would be the vertex of our parabola, and we know that it goes out 70 meters, roughly almost 71 meters, and it hits the ground. So a little over 70 is where the arrow would hit the ground. So our parabolic trajectory would look something like that.